So for PiCaS we need to define what a token looks like, as both the client and the server side have to deal with this structure. What we are essentially creating here is a queue where running jobs fetch tokens from the beginning of the queue and modify them so they are no longer part of it. For that reason we have to define a number of variables which will be part of every token. This is basically just a convention. So we first need a lock, and it will contain a timestamp converted to seconds, so basically just a large integer. This parameter will indicate whether a token has been claimed by a worker node and is set by that worker node when it starts the work that the token represents. The done field also contains a timestamp, but is set once the job completes. The difference between done and lock gives you the number of seconds the job took to complete. The type field indicates what type of token we are dealing with. You can use this to have multiple types of work in the same database, so there's nothing unique about type, it's just a method of indicating what type of token you're dealing with. The hostname is a string containing the hostname of the latest machine that modified the token. This is not really necessary for the job scheduling, but is nice to have for debugging purposes. We also include a scrub count. We want to keep track of how often a token needs to be reset before it completes. This tells us something about how complex or error-prone tokens were. Again, this is more for debugging purposes. We can also specify in and output fields. These fields are dictionaries, as every field is in CouchDB, so they're key value pairs, and contain anything that you want. As they are not actually part of the scheduling mechanism, you could also leave these out and put fields directly into the document itself. How you arrange this kind of structure is really up to you. You can put anything in the documents that you want, as long as you keep the fields that we have defined in this slide the same. So we can use this information to create the views, and keep in mind that again this is all just convention. So let's take a look at the token lifecycle. So the fields that we have shown here are the same as we had on the previous slide. So the ID and the ref fields were required by CouchDB, which is why they're in red, and the type, lock, done, hostname and scrub count are the ones that we need for our tokens. So the identifier field is set by us. We chose a particular name and that's it. And once you upload that token or document in this case to CouchDB, CouchDB itself will generate the revision number. So the one on the front is actually the number, so the revision number itself, and then a random hash follows to circumvent the problem of collisions when you do multiple updates. The type that we chose is just perm1 token, so a particular run name for example, and then we set the lock to 0, done to 0, hostname to an empty string because we're not interested in the machine that uploaded the token, and the scrub count also to 0. So once a token is claimed by a worker node, you need to have it locked. So the ID field will of course stay the same, but the revision number, once it has been updated on the CouchDB server, will have changed. So it will be incremented to 2 with another random hash after. So the type will of course stay the same. Lock will change because now the token has been locked, and this is just a number representing the time. It's not done yet, so we keep that the same. The hostname is changed to whatever the hostname is that changed the token itself, in this case node 01, and the scrub count stays 0. So now the process continues and starts working on the application that needs to be run. Once it has completed, we need to tell the database that this is the case. So we go to the done state. Again, identifier of course stays the same. The revision number goes to 3 with some random hash. Type stays the same. The lock time stays the same. And then of course you need to indicate that the token is done, which again is just a timestamp converted to seconds. Hostname stays the same, and scrub count of course also stays the same. So what happens when a job cannot complete? So what you need to do then is to remove some of the things that we've already said and to up the scrub count. So here a job has failed and a user, for example, decides to scrub the token and make it available for retrieval once again. So still we of course keep the same identifier, but now we need to go to a different revision. So we are still going to go to the third revision of that same token because it has never been completed. And what you see is that even though it has the same 3 revision number, the hash that actually follows it is different from the one that it would have been if it had been done. So this makes sure that, again, no collision can occur between different documents. So the type still stays the same and lock is being reset to 0. The token isn't done, so that stays 0, hostname stays the same, and scrub count is being incremented to 1. So we now know that the token has been tried on a worker node one time, but it has failed, and that we can now resubmit the same token to a different worker node. So now that we have the token structure and know the way in which these tokens will be modified, we can also create different views. The most important view that you will need to create is the one that creates the queues that the client will retrieve the tokens from, which we call the to-do view. The code is on the slide, and in this case it's JavaScript, so let's walk through it. For these views we only need to write the map part of the query, as there's nothing to reduce. The first line is required by CouchDB, so the function doc line, and tells you what information you get. In this case you get one document at a time, so keep in mind that we're walking through this database one document at a time, which is the case for any view. On the second line you check the type of the token, just to make sure that you're not dealing with something else. So you can also put other documents into the same database that have nothing to do with your scheduling algorithm, and then you wouldn't want to omit anything that comes out of there. So you can then check whether the tokens, so once that one has matched, you can check whether the tokens has either been locked or is done. So the doc.lock is actually needs to be 0, and the done also needs to be 0. So if neither is the case, this token should be part of the queue and you can emit it. So the emit statement kind of resembles a return in other programming languages. The only difference is that you can have multiple emit statements in one function. So this is the code that is required for the to-do view, and we'll take a look at the other two as well. So the locked view shows you all the tokens that are currently in the locked state. That does not necessarily mean that the client is actively working on this token, as the process on the worker node might have crashed, and then of course need some way of determining how much time can be passed before you decide that the token can be reset or scrubbed. The only difference with the to-do view here is, or at least in terms of code, is highlighted in red. So instead of checking for an equality to 0, you now need to check if the lock has a time larger than 0. So that's the only change that you need to make to the code that was shown on the previous slide. The done view shows you all the tokens that have been completed. You now just check the done flag, which should be larger than 0 in the case that the process has completed. Now these are really minor changes that you need to make to the code to get a completely different result. The best method of getting to grips with this material is to just play around with CouchDB for a bit. Once you have experimented with the CouchDB UI, you'll see how easy and powerful this method of working is. You can just manually put in a number of tokens and try this code out yourself and see if it works. An alternative method for playing around with CouchDB is to use the services of IrishCouch, available from irishcouch.com. They host CouchDB servers for anyone who signs up. If you, for example, want to play around with PiCaS without hosting your own CouchDB server, you can try this. As long as you're not hosting large amounts of data or making many requests, this service was completely free. And of course, see their site for billing information.